And now it's time to go to France. This presentation will take place from Pauline Letortu. I'm sorry for the pronunciation of your name. She's coming from European University Marine Institute from France, and she will present to us the contribution of oblique satellite imagery to monitor and understand coastal cliff erosion in France and in Greece.
Thank you, Nikki. So, hello, my name is Pauline Letortu. I'm lecturer in geography at the University of Western Brittany, member of the CU Alliance, previously described by Richien Gauchi. So it's an honor to present my research on the contribution of oblique satellite imagery to monitor and understand coastal cliff erosion in France and Greece. This is a collective work, so I would like to mention some colleagues with whom I work: Marion Jo, Rosa Taouki, Claire Théry, Christo Delacour, Niki Velpidou, Nicolas Dodantec, etc. Coastal cliff can only retreat, and this erosion threatens people and infrastructure. Citizens, coastal managers, and elected officials ask for knowledge to improve practices and strategies for managing the cliff erosion in a context of climate change. The dynamic of cliff erosion, retreat rate, erosion modalities, the respective contribution of factors responsible for triggering falls, is incompletely understood, partly because cliffs are a complex system, and also because they have mainly been studied since the 80s, unlike beaches and dunes, which have studied for a long time. However, the coastal cliffs represent 52% of the global shoreline. To better understand this dynamic, there is a strong need for data at very high spatial resolution, with short revisit time, from 1 day to a few months, over large areas superior to 10 kilometers in order to be consistent with the management scale, which is a hydro-sedimentary style scale. And above all, 3D data on the cliff face from the foot to the top of the cliff, which is the best proxy to observe all changes. Methods have existed since the 2000s to monitor cliff face erosion that could be gathered into terrestrial methods as terrestrial laser scanning. But these methods can be expensive, requiring people on the field, and with sometimes limited spatial representativeness of the data. For spatial remote sensing, until recently, it did not meet the criteria of very high spatial resolution and 3D reconstruction of the cliff face, which, being a subvertical object, is not observable from by imaging from the vertical called nadir. But since the launch of the Pleiad satellites in 2011 and 2012, it has been possible to access spatial imagery with a resolution of 0.7 meter at nadir, with a daily revisit time, with a swath of 20 kilometers, and an oblique viewing angle up to 47 degrees that make it possible to observe the cliff face in a new way and at preferential price for research. So how the oblique satellite imagery can contribute to monitor and understand coastal cliff erosion is an emerging research topic. We are currently the unique team to explore it, thanks to 3 projects which will structure my presentation. With the financial support of the CNES, the French Space Agency, I coordinated the Aerophalid project to assess the potential of oblique and very high resolution Pleiad images for the cliff face 3D reconstruction and thus erosion monitoring. We implemented our approach in an emblematic research site, the limestone cliffs around Dieppe in Normandy, where we were ground truth data, but this site is really challenging for satellite imagery due to its northern orientation, not prone to image acquisition from meridian orbit satellites as Pleiad, due to the shading on the cliff face, viewable on the slide, and due to often disturbed weather conditions. But if it works here, it will work anywhere. We acquired 14 pairs of images for less than 3 years, according to mono and multi-date acquisitions, simultaneously to satellite acquisition. TLS and drone surveys were performed in Varangeville-sur-Mer to have ground truth data in order to assess the quality of 3D reconstruction from Pleiad images. Thanks to 3 processing chains, MICMAC, ASP, we were able to reconstruct in 3D the cliff face from Pleiad images acquired at 40 degrees. We reach a cliff face point density of 1.7 points per square meter, with an average precision error of 4 centimeters. This value allows the detection of faults using multi-source comparison greater than 100 cubic meters, which means that 69% of the faults around the studied area could be observed. The Aerophalid project has allowed us to identify bottlenecks for generalization of the developed approach. The Aerophalid project has highlighted the dependency of the 3D reconstruction quality on the environmental parameters, cliff face orientation, color variation, the need to work on sites exposed to different continental and marine factors to better identify the respective contribution of environmental factors to erosion. To better understand these issues, we propose to increase the number of study sites. The Aerophalid project has also highlighted some technical bottlenecks. Few studies and software suites are relevant to oblique imagery. There are therefore new methodologies to develop. Because it's difficult to optimize 3D processing parameters over the whole area, it will be interesting to first detect areas of change on these images and then optimize processing parameters of the 3D reconstruction only on these eroded areas. In addition, the big volume of data implies the development of semi-automated analysis methods, such as machine learning, but here again, these methods need to be adapted to oblique images, non-authoritative and non-georeferenced images. So how to improve the cliff face 3D reconstruction from Pleiad oblique imagery is the main question of the current research project called IRAP-CLES that I coordinate. The aim is to make the best use of Pleiad imagery in terms of retreat rate, erosion modalities by developing relevant, intelligible, and transposable methods to monitor and understand cliff erosion. Because the Normandy site was not the best field site for satellite imagery, we chose an optimal site in Greece, Kerry, or Letortu, because it allows to have another limestone cliff site to compare with the Normandy one, to limit the problems of shading due to the southwestern exposure for Kerry, and to limit the problem of cloud cover on the Pleiad images, to have a classical stereoscopic and tristereoscopic image acquisition easier to process than a multi-date image acquisition as in Normandy, and to benefit from knowledge and data of the coastal dynamics for many years, thanks to regular survey carried out by the National and Capodistrian University of Athens. A third site is constituted by soft cliffs to enlarge the studied cliff type, not only rocky cliffs. The site, or the choice of the sites and their surrounding, will make it possible to test the site transposability of our methods, so its potential to be generalized and transposed, so that other actors in the community can benefit from it. Thanks to the privileged research context offered by the Heracles project, a PhD thesis project will begin, called Cicero. It will begin in 2021 using the same field sites as the Heracles project. So how to generalize the use of very high resolution and oblique satellite imagery in order to improve the cliff erosion monitoring and understanding? To answer, the Cicero project will combine classical and innovative approaches. A classical approach on the cliff top by diachronic monitoring of cliff top position, to quantify annual retreat rates by GIS, included images acquired for the thesis and from archives. An innovative approach will be implemented on the cliff face by semi-automatic fault detection by machine learning, thanks to Sébastien Lefebvre from ERISA. Indeed, the satellite images of the cliff face will provide a massively multivariate dataset, either according to the characteristics of the site, cliff color, cliff height, or according to the characteristic of the acquisition trajectography of the satellite in relation to the site, time of pass. Some methods of machine learning will be used to identify faults, as the diversity of the sites should make it possible to create a training dataset varied enough to cover all configurations as well as possible. From the segmentation result and from stereo and tri-stereo image acquisition, we will be able to reconstruct in 3D the cliff face, focusing on the areas of change. The previous steps will provide erosion rate, erosion rhythms, and erosion modalities. The analysis of the erosion data will be carried out to explain the differences obtained between sites. We will also develop the outreach of our methods and results to elected officials and coastal managers to integrate satellite imagery into a toolbox for a sustainable management of coastal territory. We will also try to improve the inclusion of satellite data in observation services dedicated to the coastline, as in France, the National Services of Observation called DINALIT. So to conclude, our research is original and promising because research on cliffs are quite rare, whereas they represent about 52% of the global shoreline. Only our team is working on the 3D restitution of the cliff face by oblique satellite imagery. The diversity of the study sites will make it possible to test the transposability of the methods and the representativeness of the results. The interdisciplinary project will allow the development of original machine learning methods, among others, and the proposal of applied monitoring methods. The discussion and the sharing of data, methods, and tools will allow wide scientific dissemination, especially to elected officials and managers. Thank you.
Thank you very much, Pauline, for this nice and explaining presentation. Is there any question from the participants? I don't see something in the chat, but maybe somebody would like to activate the microphone.
Yeah, it's Gaia. I would like to do a question if possible. First of all, I congratulate you for the innovative and cutting-edge approach of your research. Very interesting. I was fascinated by your approach. So, sincerely congratulations. And my question is about the last part of your presentation, the deep machine learning approach that is very, very interesting. And I would like if you already test this machine learning procedure and what are the first results?
Thank you for your question. No, we just at the first step of machine learning methods. So tomorrow I will try some beginning, studies, but it's really at the early stage of our research. So we try to collaborate a lot with some colleagues who have lots of experiences on machine learning, because it's really hard work to do.
Yes, absolutely, absolutely. And do you think that you will use the 3D data of oblique satellite image to test this procedure?
Yes, but I think we will try on a multi-source with multi-source data, because we have also ground truth data from terrestrial laser scanning and also drone data. And so I think maybe the combination could be really interesting to have a good training data set and so to have good results.
Oh, thank you. I certainly follow your research. Thank you so much.
Thank you very much for your presentation.